The second part of Lesson 1.4 has us solving linear systems that include 3 equations with 3 variables. To get started, we're going to actually pretty much fill that entire left-hand column, meaning I'm going to go to a new slide. When solving systems of 3 equations with 3 variables, your answer is going to be an ordered triple. So now instead of x and y, we may have x, y, and z, or k, l, and m. Whatever order we have, put them alphabetical. Graphing is not an option, so we're not going to be able to graph to solve. With 3 variables, we would need a 3D coordinate plane. Substitution can get messy. If you substitute with more than 2 variables, we're going to have a lot of fractions. That means elimination is going to be the most efficient method. And we're going to run this process very similar to what we did in day 1. All right, to solve, we have a set of 4 steps. We're always going to have kind of an algorithm to follow. Step 1 is really easy. Look at all 3 columns and pick a variable to eliminate. You have to be able to eliminate it out of all the equations. Technically, it doesn't matter which one you pick, but hopefully you'll find one that's easy to work with within all 3. Step 2, once you find that variable to eliminate, you want to eliminate out of all 3 equations and create a smaller system. So we'll create a smaller system by eliminating twice. And I'll show you with an example what that means. The smaller system will be 2 equations with 2 variables. And that we know how to solve, so that will be step 3. Solve the smaller system. Hopefully you have enough room to write our final step. Once you know the 2 variables in that smaller system for step 3, go back and determine your original variable, meaning plug it back into one of the beginning equations. It will be a lot of substitution, and you are going to want to show all of your work, so show all steps and keep it organized. That'll be the best way to kind of follow the process. Our first example at the right says, what is the solution to the system? Notice we have x, y, and z. What I'm going to do next to each one of them is label them equation 1, 2, and 3. And this will help us when we do our step 2, creating our smaller system. So equation 1, equation 2, and equation 3. Look at each column of variables. We have x's, y's, and z's. Decide which variable looks like it would be the easiest to eliminate. Well, if you look at any of the 3 columns, none of them really look that bad. They all look pretty manageable to deal with. So I'm going to go with eliminating x's. Step 1, I'm just going to say that that's the variable I'm eliminating. Now what we have to do is combine our equations in such a way where we can eliminate x twice and create that smaller system. That's step 2. So if I look at how easy it will be to eliminate x's, what I'm going to look for is combining the equations. I notice right away that equation 2 and 3, the x's would already cancel out. So what I'm going to do is just add equations 2 and 3 together. So I'm going to write equation 2 plus equation 3. And then down below, I'll show that in action. Negative x plus 2y plus z equals 3. That's a z right there. Make sure you can read those. And then plain x plus 2y plus 3z is equal to 13. As I combine my columns, notice the x's eliminate. We have 4y plus 4z is equal to 16. Now remember we said we had to do this twice, so now we have to do this again. We can't pick 2 and 3 again, so I either need to pick 1 and 2 or 1 and 3. I like the idea of picking 1 and 2 because they're opposite signs. So as long as I double equation 2, then they would be the same coefficient. What I'm going to do then is take equation 1, and then I'm going to add to that 2 times equation 2. Let's see what that looks like. Equation 1, 2x plus y minus z is equal to negative 10. And if I double that second equation, we get negative 2x plus 4y plus 2z is equal to 6. Combine your columns, the x is eliminated again. It has to be the same variable. And we end up with 5y plus 1z is equal to negative 4. That's step 2. So notice our answers both have y and z in them. That will help bring us up to step 3. Solve that smaller system. 4y plus 4z is equal to 16. Right below it, 5y plus z is equal to negative 4. If I multiply that second row by negative 4, I'll get my z's to eliminate. Keep the first equation as is. 4y plus 4z is equal to 16. But then I'm going to distribute negative 4 into the left side and the right side. That gives us negative 20y minus 4z is equal to positive 16. When I combine my columns, 4y minus 20y is negative 16y. Notice the z's eliminate, and 16 plus 16 on the right is 32. To get y by itself, divide both sides by negative 16, and y is equal to negative 2. We're still in this step, however, because we need to get z by itself as well. If I look up at the very beginning, I notice that we had 5y plus z is equal to negative 4. I'm going to plug in negative 2 for y and see what I get as my output. 5 times negative 2 is negative 10, plus z is equal to negative 4. Moving negative 10 to the right, we'd add, and we get z is equal to 6. That's step 3. We've solved that smaller system. Step 4, find that missing variable from the very beginning. So now pick one of your 3 equations, doesn't matter which one it is. I'm going to pick equation 3 because x will be easy to isolate. X plus 2y plus 3z is equal to 13. If we substitute in negative 2 for y and 6 for z, we get x plus 2 times negative 2 plus 3 times 6 is equal to 13. Then we have x minus 4 plus 18. Negative 4 plus 18 is 14. Subtract 14 to move it over, and I'm out of room right here. 13 minus 14 is negative 1. There's our other missing variable. Last but not least, write your answer as an ordered triple in alphabetical order. We would have negative 1, negative 2, and 6. Here's another practice example, now with a, b, and c instead of x, y, and z. Same process, we'll pick a variable to eliminate, create the smaller system, solve that system, and then find the missing variable. Look at the a's, the b's, and the c's. They have some similarities, and none of them I don't think look any easier or more challenging to get isolated than the others. I do notice that the A has a negative in there, which would mean there's less negative work that I have to do to eliminate. So when I look at this, I'm going to go for eliminating the A's. That's going to be my first step. A's are gone. I'm going to label equation 1, 2, and 3 again. And that just helps with our second step. Let's create that smaller system. Kind of like last time, I recognize right away that equations 2 and 3 would eliminate the a values. I'll take equation 2 plus equation 3. And that gives us 4a plus 3b, and 3c is equal to negative 6. Negative 4a plus 3b and plus 3c is equal to positive 9. The a's eliminate, and that's what I wanted. We're left over with 6b plus 6c is equal to 3. And now we have to look at what's left over. We can't use 2 and 3 again. We could do 1 and 2 or 1 and 3. I recognize at least with 1 and 3 that the a's are opposite signs, but I'm going to have to change both rows. 4 and 5, the smallest number they go into is 20. That means I'm going to multiply equation 1 by 4. And that would give me 20a. And then I'm going to multiply equation 3 by 5. So we're going to get some big numbers on this one. And that should eliminate the a values. If we multiply everything in equation 1 by 4, we get 20a plus 20b, and then plus 20c. On the right, negative 20 times 4 is negative 80. Everything in equation 3, if we multiply by 5, we get negative 20a, which is what we wanted. And then we get 15b and 15c. And then on the right, we get 45. The a's eliminate again, but now we have a whopping 35b plus 35c is equal to negative 35. Now take the system that you found, or the smaller system that we've created, and we'll solve. We have 6b, 6c, and 3, 35b, 35c, and negative 35. The easiest way to solve this one is to eliminate something in each row, or actually change each row to eliminate a column. I think we're going to have to just multiply one equation by negative 35 and the other equation by 6. Negative 35 times 6 is negative 210. And that would be times b. Negative 210 times c. And negative 35 times 3 is negative 105. 6 times all of that would be positive 210 plus 210c. Uh-oh, we're in trouble here, because then we still get negative 105 on the right. Notice this is a situation where both the b's and the c's cancel, but we actually have negative 210 on the right, which means that's false. If that's a false statement, unfortunately, this is no solution. Or you can write NS. We will solve the rest of the equations and the word problem tomorrow in class.